Uh, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Respectful greetings to the project manager, reviewers, and all participants. On this occasion, we would like to present our project-based learning benchmark for the midterm assessment entitled Design and Development of and Conventional Control of Cartesian Machine. This presentation will cover the background of the project, objective, design process, progress, results, as well as the obstacle encountered and the solutions implemented during the project execution. Next slide. There are table of contents of our project. This slide, there are our group. First from me, my name is Ahmad Farid Hizbullah as a leader team and team coordinator of this team.
I'm Brilliana Evaporani Faatihah and I'm the PIC for the second shell stage.
My name is Immanuel Ricardo Manurung, and my role in this PBL project is a PIC of Mechanical.
And my name is 𝗏𝗏𝗵𝗏 as member and PIC of for the electrical stage.
In this slide, I will explain about the background of our project, which contain an introduction of our Cartesian machine. So, Cartesian machine are one of the important devices in industry for precision movement on the X and Z axis. Generally, this machine use high efficiency controls, making them less affordable for basic learning. Students need an alternative Cartesian machine with simpler and more economical conventional controls. These projects aim to design and build such a machine as a medium learning mechanics and control system.
And now I'd like to share the main objective of our project. Our first objective is to design and build a Cartesian machine that operates using a conventional control system, not a CNC system. The second objective is to understand the working principles of the Cartesian coordinate system, especially how the X and Z axis function in machine motion. Next, we aim to integrate the mechanical system with a simple manual control circuit, allowing users to learn automation concepts in a more accessible way. And finally, our goal is to develop a functional prototype that can be used as a training tool for students to study the basics of automation.
This is the progress we have made. During the first to 4 weeks, we collect information and data to complete the project implementation plan so that it could process to the next stage. In the 5th week, we submit the project implementation plan results and work plan to the project manager and head of the study program for signing. This was followed by the creation of a work plan, acrylic design, and submission of a form for the measurement of acrylic BHP. Then, in the 6th week, we submit the sign form to the lab technician for the laser cutting process on the acrylic. This was followed by the submission of forms for lead screw and aluminum shaft materials. We filled the acrylic and cut the lead screw and aluminum shaft according to the design. And in the 7th week, we assembled the acrylic to form the machine base. This was followed by the submission of forms for electrical BHP. Next. From the past few weeks, here are the results we have obtained. The image on the left showed the results of cutting in week 6, namely the aluminum shaft and lead screw. The image in the middle shows the acrylic after going through the design, laser cutting, and filling process. The image on the right shows the results of assembly in week 7, where the acrylic was assembled to form the machine base. Okay, next.
Sorry. In this slide, I would like to share our obstacles. During the design and development process of the conventional control Kartesian machine, our team encountered several challenges. The main obstacle were the limited availability of required materials and components, which caused delays in certain stage of the project. In addition, some components had to be sourced from external suppliers, resulting in extended procurement time. And also, we have two solutions for our problems. The first solution is to address the limited availability of materials. The team adjusted the project timeline and prioritized tasks that were not directly dependent on the unavailable components. We also optimized the use of existing materials without compromising the primary function of the system. The second solution is for external component procurement, that is for components that needed to be sourced externally. The team initiated early coordination and identified early condition and identified alternative components with equivalent specification to ensure the project could continue according to the learning objective.
Okay, as we see in the slide, these are some of the knowledge and benefits that we gained during the PBL process. First, we became more skilled in mechanical aspects, such as cutting, filling, and assembling machines. Second, we learned to use design software to assist component manufacturing process, such as using AutoCAD. And the last one in this project improve our teamwork skills, such as how to coordinate, divide tasks, and solve problems together.
Following that explanation about the benefits, I'll now talk about our work plan for the next stage. First, we'll start by completing the mechanical work, which includes finishing the remaining parts such as the aluminum subfolders and completing the overall assembly. Once the mechanical part is done, we'll proceed with the electrical work, where we'll assemble all the electrical components onto the miniature CNC. After that, we'll move on to developing the sequential control, where we'll create and test the motor movement and control system. When everything is set up, we'll conduct machine testing to ensure the Cartesian machine operates correctly and meets the design guidelines. And finally, we'll work on reporting, preparing both the final report and the presentation to summarize our progress and results.
Thank you. This concludes our presentation for the midterm assessment benchmark. Thank you for your attention.